Okay, so today we'll talk about the three things: AWS Green Grass, how to build your own drone, 3D print your drone, design and 3D print your drone, and then how to use Autodesk Recap and drone and the AWS Green Grass to aerial photograph the photograph of a site and build a 3D model. So let's go agenda. So let's talk about AWS Green Grass first. So AWS Green Grass is basically for edge computing. So people who know IoT is all about connecting your sensors. So when your sensors are generating a lot of data, and some critical decision has to be taken at the site where at the point where the data is generated. So if you are sending the data to AWS cloud and taking the decision, by the time the data comes back, probably the event would have lapsed. For example, the Tesla car. If you're going to Tesla and there's an accident going to happen, you have to take the decision at the point of where the incident is happening. So you can't send the data to cloud and take a decision and come back whether to apply the brake or not. So AWS GreenGrass is a solution for that. It's called edge computing. So what AWS GreenGrass gives you is it gives you an SDK. You take that SDK and flash it onto your hardware like Raspberry Pi or something like that, and then you can take all the cloud decisions that you are supposed to make on AWS cloud. You can actually do it on your local Raspberry Pi or any other hardware. So basically, what it does is you have a lot of sensors here, and these are the typical IoT world. You have sensors, you send the data to the cloud, and then the cloud you store the data, and then you take based on the data that's coming in, you actually take some actions like say you might send an email, SMS alert, or something like that. But that is actually not very useful in most of the critical situations. So what we need to do is we need to process the data at the source where the data is generated. We need to process that. So as part of that, we have uh, AWS GreenGrass. So what are the value of processing the data at source? Laws of physics. Laws of physics says that anything that has to travel, it takes some time. So to reduce the latency from sending the data from the source to the cloud, you need to use something that can process the data right at the source. So that is the laws of physics. Because of laws of physics, we need to ensure that the data, you process the data as soon as possible. The second law says that laws of economics. Uh, in a typical AWS IoT scenario, what happens is your sensors are generating data every second or every like every 500 milliseconds, and all the data might not be useful to you. You might want to process only certain bits of critical information. So if you are able to actually process only the critical information and send only the important information to the cloud, it actually saves you money. So laws of economics dictate that you need to actually have process only the critical information that is required. In a typical, say, if you take an Boeing 747, which can fly, if it flies for 4 hours, it actually generates 1 terabytes of information. And all those 1 terabytes of information, you don't have to actually pump in into the your database. You might need only the critical information that is required. So you can actually process at the source and then only store the local things. And finally, the laws of the land. Laws of the land says there might be privacy issue or some government regulations might be there. So based on that, it might be required that the data has to be within that source. It doesn't have to go out or something like that. So based on laws of the land, you might have to do process the data at the source. So all this requirement is actually kind of satisfied by AWS GreenGrass. So if you see the structure here, earlier you saw that there were sensors are sending the data to the cloud, and the data is to be processed at the cloud, and then action is to be happening at the cloud. Now what happens is you have the sensors. The sensors will send the data to the gateway, which is right at the source, and the gateway has AWS GreenGrass in it, and AWS GreenGrass will process that data and can take the action there itself right at the source. It doesn't have to actually go to the cloud. That's not a necessary condition that for AWS GreenGrass to work. So what are the benefits of using AWS GreenGrass? Like I said, response to local events quickly. There's some event happening, and you can actually take a very quick action for the events that are happening on the on-site. Then you can operate offline. In one of the critical, one of the conditions, one of the scenarios where IoTs are typically deployed is you are not always guaranteed that you are connected to the internet. Then your connection can go offline or something like that. So you need to operate offline. So AWS GreenGrass SDK provides you that option. So all your data is actually managed by AWS GreenGrass SDK on your local gateway, and whenever the connection is available, it will actually send that data back to the cloud. So it will does the syncing and all those things for you. Simplified device programming. So AWS GreenGrass will use the same programming that we are all aware of, AWS programming APIs. So you can use the same APIs, and you don't have to worry about syncing, and you don't have to worry whether the internet is there or not, or all those things. And one more other good advantage of AWS GreenGrass is you can actually have Python Lambda functions running right on your local source. You don't have to go to AWS to run your Lambda functions. You can actually run it right on your local gateway. And last, reduce the cost of IoT applications. How to reduce the cost? Like I said, like a Boeing 747 flying for 4 hours generates 1 terabyte of the data. If you're sending 1 terabyte of data to cloud, it costs you money. Instead of that, if you can actually send only the critical information, it can reduce the cost of your IoT applications. So we covered AWS GreenGrass. Now let's go to how to make a drone. Okay, so yeah, in this figure, I built a drone, my own custom drone I designed. So I took Autodesk Fusion 360. I designed my own custom drone using a Fusion 360, and then I used a hardware called PIXHAWK. PIXHAWK is an open source autopilot hardware for drones. You have complete control over that, and you can connect all kinds of sensors, GPS, your ultrasound sensors, and all those things. And this is a schematic diagram for how to connect all those things. I'll show in a video how actually it builds up. So what I did was, first I went to Autodesk Fusion 360. I designed a drone, and then I 3D printed that. Then I had ordered this hardware, assembled the hardware, and then what I did was I mounted a camera onto the drone, and then I took the Raspberry Pi and flashed AWS GreenGrass. So all the information. So this has lot of sensors connected. It has GPS constantly being fed, and the battery information. A lot of these almost has 10 different kinds of sensors constantly feeding. Every 250 milliseconds, some kind of data is being pushed. So all this data you can actually store in your GreenGrass, and finally, when you have some kind of a connection, you can push it back to your AWS cloud for later usage. So this is a video of your iPhone Maps application, Apple Maps application. If you have seen this, there's an option. If you go search any US region, you can actually 3D. You'll get a 3D maps. So you can actually have a 3D aerial view of any of the regions. So this is a New York region that I'm showing here. So you can see that there's a 3D map. So how you can actually build this using your own drone? That's what I'm actually going to show you here. So you can build your own drone, then use Autodesk Recap software to actually stitch the photos and make this kind of aerial 3D mapping. So there's a small video just
the custom design and built drones would be mounted with an Android phone that can be programmed to capture the scene as it flies, and then send their captured photos directly to Recap APIs using the phone's 4G connection. To achieve this, we started with custom design and 3D printing parts of the drone using Autodesk Fusion 360. The drone flies autonomously using PIXHAWK Autopilot and can be controlled via Android phone. Once the drone is built and tested, we move to develop the Android application to capture the scene as the drone flies and send the captured photos at different waypoints to Autodesk Recap APIs, which is part of Forge platform. Recap API does the hard work of converting our physical world captures into virtual 3D drawings. Use Recap on drone to 3D aerial scan, site survey and other applications.
So this actually shows how the drone was built. The next part will be mostly covering how we can use
Reality
recap,
capture is changing the
reality
way we
capture,
survey.
to
It's a
actually
process
stitch all
that
the photos to
captures,
generate
measures,
3D,
and maps
uh,
millions of surface
3D
points
models.
to build a textured, high-resolution, precise 3D model of your site. You'll be able to scan quickly and accurately, making it easier to survey, plan, renovate, and construct new buildings or infrastructure. You can scan sites faster and easier than ever before using reality capture. Kickstart your project with reality capture in 3 steps. First, gather detailed data using LiDAR or photogrammetry technology. A camera mounted to a drone can scan the site in hours, not days. Next, Recap Pro automatically registers, cleans up, and analyzes the data. The end result is a point cloud, or mesh, that is ready to use with CAD and 3D modeling software. Finally, once you've imported the data, you're ready to start designing.
This ends the video. So what you saw actually was how we actually designed the uh, drone, and then how did we 3D print, and then how did we mounted basically I mounted an Android phone to the drone, and then program the drone to fly over certain area, and it can actually take photos at certain intervals, store the data, and I'll send all this information to store it in AWS GreenGrass. And whenever net is available, it will actually send it to Autodesk Reality Capture. And Autodesk Reality Capture will do the hard work of stitching the photos and generating you the 3D model. So you can actually, at the end result, will be having a 3D model of the site that you actually scanned using your drone. So Apple was using helicopters. They actually flew helicopter over the entire New York region to actually generate that entire 3D map. Now the technology is so cheap. This drones will be costing you around $800, and other AWS Green Grass, it's actually free for up to 3 sensors for 1 year, and then you have to use reality capture, Autodesk reality capture to stitch the photos. So that actually ends the demo. Open for questions. Thank you.